Hello and welcome to today's highlight webinar, Cognitive Enhancement, presented by Dr. Pattie Maes from MIT. I'm Leah Adamson, the Events Officer for the Institute for Molecular Science and Engineering. The Institute for Molecular Science and Engineering is one of Imperial College London's global institutes, drawing on the strength of its 4 faculties to address some of the grand challenges facing the world today. The Institute's activities are focused on tackling problems where molecular innovation plays a role. Before we begin this webinar, I'm going to put a few links into the chat function. So these links will include our Eventbrite page, where you can see all of our upcoming events. This also includes the panel discussion that we'll be having on the 29th of April, where art and cultural heritage meet science. A link to our briefing papers, our podcast, and also our newsletter registration so that you can keep up to date with all of our IMSI news and events. So before we begin, I just wanted to give a few top tips to make sure that we can have a really good session. So please make sure your microphone and video are switched off. As attendees, they should already be, but please do just double check. If you have any questions pertaining to the webinar, please put these questions in the Q&A function. If you have any questions about any technical issues or accessibility issues, then please do message me on IMSI Imperial privately in the chat function, and I will try and help you where possible. So I will now hand over to Dr. Ali Yetisen. He is a senior lecturer in the Department for Chemical Engineering, and he is also going to be the chair for the Q&A portion of the session. So I'll hand over to him now to introduce our speaker for today. Thank you very much.
Thank you, Leah. Hello and welcome to this IMSI webinar. I'm your host, Ali Yetisen. I hope you will enjoy today's webinar. It's a great pleasure to have Professor Pattie Maes of MIT Media Lab with us today. In her talk, Professor Maes will provide insights about cognitive enhancement. Her innovative approach in human-machine experience is very unique, and watch out for this space in the upcoming years. She works in the MIT Media Lab, which is an interdisciplinary research center where scientists, engineers, artists, even entrepreneurs come together to build creative technologies. When I was a postdoc in Boston, I was very fortunate enough to collaborate with some of these exciting researchers from this ecosystem. Feel free to browse our collaborative project, Dermal Abyss. Professor Maes directs MIT's program in media arts and sciences. Until recently, she served as an academic head. She runs the Media Lab's Fluid Interfaces research group, and coming from a background in AI and human-computer interaction, she explores cognitive enhancement and how immersive and wearable systems can actively assist people with learning, communication, and well-being. Professor Maes has been an active entrepreneur. I think this is one of the main sort of her characteristics as well. And she's been a co-founder of several venture-backed companies, including Firefly Networks, Open Ratings, and Tulip. Please join me welcoming Professor Pattie Maes.
Thank you very much, Ali. So welcome everybody, good afternoon. So as Ali mentioned, my background is in artificial intelligence, but for the last 30 years, really, since I've been a faculty member at the MIT Media Lab, I have been much more interested in augmenting human intelligence or augmenting human cognition rather than building programs and robots, etc., that can show human level intelligence. And so this whole topic of augmenting intelligence, augmenting cognition, supporting people with cognitive functions is what I'll be talking about today. So as you all know, digital devices today put the world's knowledge at our fingertips, but you could argue that they don't really improve our well-being and performance all that much. Many studies are coming out every day showing how there are negative impacts on people's physical health, people's mental health, people's emotional health of sort of these devices such as smartphones, smartwatches, laptops being used 24/7. I'm curious in my work or I'm looking at the question of whether these devices that we now carry with us all the time, whether they can actually help us with well-being and with growing certain cognitive skills. All of us want to change or grow in some way. Maybe some of us want to develop better and healthier habits, or others may want to improve their ability to focus and sustain their attention. Yet others may need help with strengthening memory function or becoming better communicators. Many of us want to be less controlled by our emotions, and others may be interested in being more rational decision makers, or at times maybe being a little bit less rational and being able to be more creative thinkers. The current solutions for personal growth are far from perfect. If we want to change one of these things about ourselves and grow and become a better version of ourselves, we may resort to self-help books or videos, self-help videos. Maybe we go see a therapist or a coach, or others may resort to chemicals and drugs to basically change sort of and improve these aspects of our cognition. I believe that given that we are now always carrying these digital technologies with us everywhere, our smartphones, our watches, etc., and Fitbits, other things like this, that there is a huge opportunity for these wearables, or sometimes we call them nearables if they're close to the body, to support people in the moment with all of these cognitive functions that we just talked about. So in all of the work that I do, we typically build wearables or nearables that do some real-time sensing of a person. Maybe they do physiological sensing, EEG, EMG, movement, audio, visual, voice, chemical sensing in some cases as well. And they interpret all that data in real time to then issue some real-time interventions or feedback to the person that can help the person with whatever the sort of function is that they need help with: attention, emotion control, etc. These real-time interventions also take multiple forms. Some are in audio form, visual, tactile, symbolic, olfactory, temperature, pressure, electrical stimulation, and more. I'll give you a lot of examples today to sort of illustrate all of this work. Now, I mentioned also, or Ali mentioned in the beginning, that my main field these days is that of human-computer interaction. I come from AI, but I've really been publishing primarily in human-computer interaction. And in human-computer interaction, the work that has been done really over the last 40, 50 years since the field has existed, they have taken a certain approach to how people interact with devices that is very different from what I am, what we have been working on in my research group. And it's basically the systems that we are building are designed radically differently from the typical apps and so on that a person interacts with on their phone today. I'll talk a little bit throughout the talk and the examples I give about the philosophy of this approach that we are pushing, which is very different, again, from sort of the typical human-computer interaction field and typical apps and services that you use your phone and your smartwatches and so on for today. So one difference is actually that we are very interested in going beyond seeing your devices as tools and your apps that you use as tools that you invoke to do something. And we actually look at the design of systems from the perspective of integration between people and machines. So in HCI, or human-computer interaction, and today's devices that you use, interaction means tool use. If you want to use your phone for something, you have to invoke an app and make it do something. It's kind of like picking up a hammer to hit a nail. Instead, in the work that we do on augmentation, interaction between the human and the device is more one of integration. Some of you may be familiar with the writings of Kleins and Klein, Manfred Kleins and Nathan Klein, who coined the term cyborg. They talked in the 60s, they wrote this several famous papers where they basically talk about how we can create artificial organs for people that can take care of certain functions on behalf of people, so that the person themselves is less bothered or doesn't have to think about maintaining that function or performing that function to keep themselves alive, for example, in space. Or so it's basically liberating them. There is an organ, an artificial organ that takes care of a certain function, so that the person themselves can basically be free to create, to think, etc., to feel, because they have delegated some task to a device. Let me give you an example of our work that shows this integration. Many of you may be aware of the problem with virtual reality systems, that they cause motion sickness, and people often can't stand being in them very long, because their eyes and their vestibular system are basically not getting the same types of signals that are in sync with one another, and that is what causes the motion sickness. So we have been building a device, pictured here, the MoveU device, which actually stimulates the vestibular system with electrical stimulation. So you put this around your neck and you attach an electrode behind each ear, and we can basically stimulate that vestibular system to basically think that the body is moving in a particular way when it isn't. And so we can stimulate it to think that you are moving left, or to think that you are moving right, without you actually moving left or right. We have tested this system in virtual reality. And so based on the movements that you see visually, we give you the appropriate stimulation so that your body gets the same inputs or inputs that are in sync from the vestibular system as well as from your eyes. And we showed that reduces the nausea significantly, and it also gives people more of a sense of really being present in the virtual world, because they get an additional modality, sort of, where the signals that they are perceiving seem to be correct. We also, in the bottom two pictures there, we started testing the same system for car sickness on the MIT campus by having students sit in the back of the bus that you see on the right there, that goes around the campus, and you see the trajectory that it follows on the left. And we made them read in the back of the bus, which is typically something that will give a lot of people nausea, especially with that bus making so many turns. And unfortunately, we haven't been able to finish these experiments because of COVID, but the initial results for the people that we tried it on so far show that they are able to read and keep reading in the back of the bus when we give them that appropriate stimulation to counter the motion sickness. A second difference in our work compared to how, again, computers and cell phone apps are designed today is that our work is much more informed by psychology and neuroscience. If you take, again, what regular developers of digital services and apps do, they assume that the user of an app is very rational, and they don't consider the actual irrational nature of human cognition and behavior, as well as the unique properties of our brains and our memory and so on when these apps are being designed. So instead, in our work, we are typically inspired by insights and readings, literature from psychology and neuroscience that then inspires a wearable device that can enhance a particular function in the wild. But then those wearables that we build, they actually offer new opportunities for studies and for new products and services as well. But the opportunities for new studies can then actually contribute again to new insights in psychology and neuroscience. Let me give you some examples. Another system that we have been working on is the Nevermind system, it's called, which supports memorization, which helps people with memorizing and recalling facts. What the main idea of this system is that we were inspired basically by the fact that people have very different types of memory, factual memory, episodic memory. There's even spatial or cells in the brain that have been discovered that show that we have some unique hardware to remember routes and spaces. And so we thought, well, can we make use of this basically this sort of unique ability that people have to remember spaces to help them with factual memory, with remembering facts. Specifically, we took the Super Bowl winners of the last 30 plus years. The Super Bowl is, of course, in the US, the most important sports event, American football event. And we made people basically study who the subsequent winners were of the Super Bowl, starting in the 60s all the way to now. And we had one group use paper. They would see the list on paper and memorize it. And we had another group that used a system that superimposes a picture to remind the person of each winner of each consecutive year. They see a picture that will help them remember that in their visual field, superimposed by these augmented reality glasses that you see on the left. And they basically, we make people follow a route that they know very well. In our case, it was from the subway station to the office of the person at MIT. And along the route that they follow, we show them pictures that are superimposed on their visual field that will remind them of the different winners for each year. So we have teams like the Green Bay Packers or the New York Jets, etc. And we chose a picture for each one of them. Like for the Green Bay Packers, we found a guy with lots of boxes, and we show that picture to the individual, the subject in our study, when they first come out of the subway station, because the first year that you have to remember the winner for is 67, when the Green Bay Packers won. In 68, the Green Bay Packers won again. And so as you go up the escalator to go out of the subway station, we show another guy with lots of boxes. Then in 69, the New York Jets win. one. And so we show a jet in your visual field as if it's parked right there when you come out of the subway station, and so on and so on. So we basically give you an image for each winner, and you just go about your route or your your commute basically from the subway to your office, and you see all these pictures added to your surroundings to help you memorize this set of facts. What we showed is that the people who study, so to speak, this way, they actually initially, the two groups, the group that studied on paper and the group that used our system, which is called Nevermind, initially they perform about equally good, equally well, and they can both remember the different winners and recall them. But already 24 hours later, the group that actually used paper to study has forgotten more than half of the correct winners, while the group that used our system, they have effectively, we think, used a different part of their brain to memorize these facts, and they can just in their mind recall their route from the subway station to their office and remember, oh yeah, first I saw a guy with boxes, then when I went up the escalator I saw another guy with boxes, then when I came out I saw a guy with I saw a picture of a jet, and so on. And they actually are able to recall and recreate this sequence of winners. We only tested it up to 7 days after, but anecdotal evidence from people that were in the study shows that they can keep repeating this for even 6 months later because they use different machinery, so to speak, in their brain to remember this task. So we think that there's a lot of interesting things like that that could be done to change how technology assists us if technology actually was inspired more by actual knowledge of how our brains work. A third difference between our work and, again, how we interact with devices today is that the systems we build when we do this augmentation work and integration work, typically the functionality is triggered automatically by what a person is doing and by their behavior. Instead, today, when you want to do something again with your phone, you have to like start an app deliberately yourself. But in the systems we built, they are typically always on, and interaction is automatically initiated by the system, not just by the user. Let me give you another project that we have been working on for over 5 years now that illustrates that, and that is the Attentive U System. It is a system that consists of EEG sensors, so brainwave activity sensors behind the ears, as well as EOG, or eye movement sensors built into the sort of bridge of the glasses. So we built those sensors into the form factor of a pair of glasses. We also included Bluetooth and feedback modalities in the glasses. And we can basically use some established techniques to monitor attention based on EOG and EEG, and then give feedback to people when their attention changes or drifts. We have actually, there's several things that we can pick up: external attention versus internal focus, audio versus visual, etc. What we did is, to test this system, was we had 3 groups of subjects that we forced to watch lectures in a seminar room. And one group is wearing the system and is getting real-time feedback in the form of audio, basically, every time their attention drifts, as measured by the EOG and the EEG sensors. So every time their attention drifts, we actually play a little sound to remind them to pay attention to the speaker. A second group got random feedback, whether they were attentive or not, at certain moments in the lecture. And a third group was just wearing the glasses, but not getting any reminders to be attentive. We did 3 different sessions, and 3 times actually we showed that in blue, the group that gets the biofeedback to with the reminders to be attentive when their attention drifts, they actually perform better on a test or a quiz about the material that was presented than the group that gets random feedback in gray, and the group that actually got no feedback at all in orange actually performs the least well. We on purpose actually used the form factor of glasses because the idea is that ultimately a person could just decide when they want to put on these glasses and when they want to be more focused, but they can also remove the device when they just want to be themselves and don't want to have this system reminding them to be attentive. Another difference with today's apps that you are familiar with in our work is that we look at interfacing with different states of consciousness. The apps that you use today primarily really assume that you are a conscious and attentive user of the app. We are exploring how devices, digital devices, can interact with people in different states of consciousness and attention, including, for example, sleep. Of course, I'm sure many of you are familiar with some of the sleep trackers that exist today, but those don't really interface or interact with the user during sleep. They purely monitor your sleep and tell you how you slept and how much time you spent in the different sleep stages and so on. But we think that there is a lot of opportunity for helping people with cognitive functions, all sorts of different cognitive functions, by interfacing with the sleeping mind as well as the awake mind. One example of that is this system that called Dormio that we've been working on for several years as well. It was inspired again by some literature indicating that famous creative people and innovators and researchers such as Salvador Dali, Thomas Edison, Tesla, many others, they actually consciously used dreaming as a source of inspiration. And the way they would do this, and in fact, the picture on the painting by Dali on the left is one that he credits to this process actually, or was the result of one of these sessions that he would engage in. And on the right, you see pictures of Thomas Edison. And in the sculpture there in his hometown, he is even depicted with the steel ball that he used to use this dreaming technique to come up with novel solutions and new ideas related to the problems that he was trying to solve. So the way this technique was used by these famous individuals is that they would fall asleep or nap with a heavy object in their hand, and they would force themselves to think about a particular topic or a particular problem while they were falling asleep. And as soon as they fall asleep, of course, their muscles relax and the ball or the heavy object drops down, and that then wakes them up, allowing them to capture some of the ideas that they would get, or some of the dream content that you get in the first stage of sleep, which is called hypnagogia. So hypnagogia is that stage of sleep that happens just when you transition to being awake, from being awake to falling asleep. And it is characterized by micro dreams. People have little dreams in that first phase that are actually very similar to REM dreams, the dreams that you get in the REM state. And if you can wake yourself up, basically, and if you can influence the content of those dreams, that can actually be a source of inspiration. And so we actually built a system that makes it a lot easier to use this technique, and so that you don't need as much training to do so. We have a glove with several sensors. It senses your muscle relaxing, your heart rate, and your electrodermal activity. And that glove sensor is used to detect what stage of sleep the person is in. And we have an app on the phone that actually plays custom prompts first before you fall asleep. It actually reminds you to relax and fall asleep, and it reminds you to think about a particular topic, and you can record the prompts. You can decide what it is that you want to be dreaming about. So in our experiments that you'll see in a minute, we use things like the word tree, think of a tree, think of a tree, or we used rabbits, we used a whole bunch of different sort of fairly neutral prompts to test whether we could actually incept these micro dreams and influence the content of those micro dreams to be about the topic that the system reminds you of as you are falling asleep. Based on the data from the glove, we know when to wake the person up, and we wake you up just enough by speaking, by the app speaking to you, basically asking you what it is that you were dreaming about. Often people don't completely wake up actually, but they give sort of a very dreamy report of the imagery that is was just happening in their brains. And I'll give you a particular example that actually the BBC created a visualization for. We just capture the dream reports in audio, but the BBC, when reporting about this work, made a little video to go along with it. Oops, and here's the video with the prompt of fork.
Speech about a fork. And the monkey is holding it, and they're putting it in a pumpkin, and the secret agent is using the fork to go into headquarters, and a child picks it up and throws it to a bird. And the fork is run under a sink.
So you get the idea. The interesting thing is that we can actually do this multiple times. So we wake you up a little bit to ask for a sleep report, and then we encourage you to fall asleep again and dream again of a fork or whatever the prompt is that you want to use. And by the end, when you wake up from, say, your nap, it may possibly be a less restful nap, but you have a whole set of dream reports that are otherwise very hard to remember, that you can mine for content. And I apologize, I think I don't have the slide here that shows the results, but we have a paper in the Journal of Consciousness and Cognition that shows that we can indeed influence the dream content, and most of the people dream about the prompt that was given. And second, we also tested whether people were able to be more creative when it came to an alternative uses task, which is a typical creativity task used by psychologists. We tested whether they were able to be more creative related to the prompt, say the word tree, whether they could think of more uses of a tree than other people who had just rested without falling asleep, or people who had fallen asleep but had not dreamt about and been given that prompt and dreamt about the topic of a tree. So we showed that the system actually can influence your dreams, and that second, you then as a result are more creative related to the prompt that was given. Oops. So another difference between our work and again how you use your phones and laptops and so on today is that we use bodily pathways to influence cognition. A typical interface that you use focuses again on sort of a conscious user, and uses more conscious pathways for interaction with the user, meaning language. Your phone shows you language, it speaks to you, it shows you visual images, etc. But you have to consciously interpret those, and that may influence your cognition. Instead, in our work, we often explore whether we can stimulate the senses as an indirect path to affect your cognition. So we alter your perception of your environment to change or to influence cognitive functions. Here is one example of this. A system that, again, we've been working on for several years now, called Frisson. All of you, or many of you, may be familiar with this sensation of chills running down your spine when you encounter something beautiful, listen to beautiful music, for example. It turns out that this is actually a very universal phenomenon, and that sensation is results in the person being more attentive at that moment, your memory working better. You also are more open, there's more openness towards whatever stimulus you have or person you are looking at, and increased empathy, feelings of empathy. So we built a system to try to induce this sensation of chills, which for many people also goes hand in hand with the hair on your arms standing up. So we actually did again an experiment where we had artificial chills generated by that device, by people wearing that device, at certain times while people were watching a video of Charlie Chaplin, actually, in the movie The Great Dictator. And what we show in our publications mentioned here on the right is that people, well, they report feeling chills, or the device actually gives them this same sensation of chills. And second, people show more empathy towards the subject and have increased memory recall of the video in the moments that they are given this sensation of chills. So this could potentially be used either to improve attention in a learning context, or in entertainment. We may one day have movies with an additional track for bodily temperature stimulations that heighten the emotional experience of watching a video. Related to this, we have recently started exploiting what is called a Proteus effect for a variety of cognitive functions, or to influence a variety of different cognitive functions. So we're all on Zoom all the time, of course, these days. And as you know, there are many filters available for Zoom, Snapchat filters that can turn you, the person on the left here, for example, into a child version of themselves, or into an inventor, or you can become a male or older, etc. You can change many aspects of your visual representation, basically. And it is known that the way people see themselves influences their cognitive, their behavior, basically, and their cognition. For example, people think of children and inventors as being more creative. So we thought, well, what if we show the person, we give them a creativity task, but we actually have them look at themselves on Zoom as a child version of themselves or as an inventor version of themselves versus their regular visual representation. And what we showed in this work, again, we did like a whole study. We gave them, we had each subject, it was a within subject study, sort of perform this alternative uses task, which I mentioned before, which can measure creativity of an individual. And we changed the conditions. So they had a control condition as well as the condition where they looked like an inventor and a condition where they looked like the child version of themselves. And again, we showed a slight increase in creativity. We think we can improve this effect actually, because we didn't force people to look at their own self-image basically. And we think if we make them look at it more, as opposed to maybe looking only occasionally, that the effect will be larger. But it showed that people are more creative when they see themselves as a child or when they see themselves as an inventor rather than their own persona. So the filter, just using filters can influence this Proteus effect and can actually have downstream effects on cognition. Last difference with, again, the devices you use today is that we sort of look at an extended use perspective of the systems, the services that we create. Again, today's devices, you typically use an app every once in a while. And in our work, in this augmentation work, we imagine that the person uses this day in, day out for long periods of time. One project that I'd like to illustrate this with from our group is a system where we use scent, smells basically, to influence a person's cognition and other functions as well. For example, better quality of sleep. My student, Judith Amoras, now a postdoc actually, has been building an olfactory device that can release scents in very precise quantities. It can release 3 different ones. You can choose between 3 different ones, and it can release scents based on physiological data about the individual, for example, what stage of sleep they are in, or during the daytime, what is their heart rate, what is their breathing rate, etc. And Judith has been using this device in a whole series of experiments to show that you can actually use smells to influence a person's emotions, for example, calming them down, making them more alert with peppermint, calming them down with lavender, and so on. But her most interesting work actually uses this device to basically implement the first or realize the first at-home study of targeted memory reactivation. Targeted memory reactivation is, actually I'll leave it here, is a technique that again has been documented in the literature by psychologists, where you basically associate a particular stimulus, it can be a sound or a smell, with a particular task during the day. For example, learning the names for different objects in another language, in a language you don't know. And if you then at night during slow wave sleep release or play the same stimulus, again, the same sound or the same scent, it actually improves people's recall and it improves their memory afterwards of the content that they created. Typically, people have been using, and I don't have a picture of it here, but typically these studies by psychologists are performed using a special sleep lab in the university that costs a lot of money, where there is a live person doing the sleep scoring or the staging. There is a polysomnography device which costs thousands or tens of thousands of dollars, an olfactometer. The person has lots and lots of wires. I believe it's 36 wires connected to them, basically. And that is how these targeted memory reactivation studies typically happen. In our case, we actually replaced all of that by this very simple device and some physiological sensors. The device can be worn around the neck, or you can clip it to a holder so that it can spray scent at you at night. And so this new system that we built can basically enable these new or these sleep studies in more naturalistic settings, in home settings, which is very exciting because it opens up opportunities to do a lot more research and to do it in a more realistic setting rather than in that lab, the sleep lab with tons of wires attached to the person. So we actually did the first at-home sleep learning study, the first at-home targeted memory reactivation study, where people had to learn words in another language that they weren't familiar with. And we presented a particular scent and then presented that same scent at night. And we showed that basically there is again a significant improvement in the recall for the people who got the odor, as opposed to the people who just had water, no odor, presented to them, and everything else was the same. Last difference, or last sort of principle of this new work that we are doing, is that we want devices to be easier and more sort of less cumbersome to use. Again, when I use my phone for something, I have to unlock it, find the app, etc. It takes a long time to actually well, get to whatever it is that I need on the phone. We have been doing a lot of work related to systems that take a minimal effort to use, that provide immediate access. We have been building systems, for example, that pick up signals, muscle signals, or signals you send to the muscles when you speak without actually voicing what it is you speak. And we can train a neural network to recognize a person saying, say, 1, 2, 3, etc., different words. We can pick up which word, or recognize, classify which word it is that they are saying based on these electrodes picking up these signals from the area around your chin and mouth. Most recently, we have been using this for ALS patients that have ALS or MS and who have lost the ability to control their muscles enough and to actually voice words. So this lady, for example, you'll see she cannot really make sounds, but she can still make some movements. And we train the neural network to recognize which word it is that she's trying to say, so that she doesn't have to use the eye gaze based or other input device to convey to other people what it is that she's trying to communicate. So you'll see the video.
Try that one again. 3, 2, 1, go. Thank you.
So she basically has to give a number of examples of the words "thank you," and then the system can recognize.
Try bathroom again.
3, 2, 1, go. Bathroom. Nice.
Yeah.
Okay.
So I want to summarize by saying that we are embarking on this, or we've defined this new approach in human-computer interaction, which we refer to as augmentation or cognitive augmentation. And the systems we build are typically wearable systems that assist a person with cognitive functions and other types of skills. And these devices are designed to interact and to work with a person in a radically different way than what we are used to today from the digital systems that we carry with us wherever we go. I hope I convinced you that given that people now will forever have devices with or on them, that we have an unprecedented opportunity to help people with supporting cognitive functions. But of course, there are consequences for all of this work. Marshall McLuhan famously said, every extension is an amputation. And the way I interpret this quote is to mean that whenever we delegate some responsibility or rely on something or someone for a particular task, we also lose something in the process. We lose potentially the ability to perform that task ourselves. For example, if we always relied on calculators to calculate any arithmetic expression on our behalf, we would potentially lose our sense of numbers and so on, and that may have other consequences that are not desirable. So it's important to keep this in mind. People like all of you invent things and shape and create new technologies, but those technologies also shape people and shape the world we live in and change us. So as devices become a part of us and know us intimately and help us with these cognitive functions, the ethical issues are a major concern. And in my group, we try to be very much involved in basically all of these ethics discussions, and we try to design and test and discuss these systems with target users so that we can make sure to keep these ethical considerations in mind. Some of these ethical considerations are listed here. We want to avoid over-dependence on these systems and make these systems ultimately become obsolete. They should be used to help a person with, say, becoming better able to sustain attention or being creative and so on. But we hope that as they help the person with that function, that eventually the person internalizes that skill and does no longer need the device to help them with that function. It's important that people have full understanding of how these systems work and full control, that nobody else will impose these systems on a person, but a person can choose to use one of these systems and to use it in a particular way. We also think a lot about equity and the haves and have-nots and so on. And of course, last but not least, privacy concerns with all of these systems that we are building. So I will end there and stop my screen sharing so that I can answer some questions. Thank you.
Thank you for this inspiring talk and amazing insights into technology and cognitive and behavioral neuroscience. I was especially taken by the wearable device used during the sleep and how this can shape our creative thinking. Now, I would like to invite our audience to post their questions in the chat box.
And my apologies for taking too much time, leaving not enough time for questions. So feel free to be in touch afterwards with questions.
Pre-submitted question from an audience. A huge portion of the economy is entirely driven to monopolize as much as our attention as possible. Mm-hmm. This could have a detrimental consequences on developing children and young adults especially. how can we change this dynamic using more technology?
Yes. Yeah, so very good question. I've been around long enough that I've seen changes in business models for software and computer services. It used to be that we had to pay for software. And of course, in the last 15 years or so, software, a lot of software, especially software that is that is intended for general consumer, is free, is basically free. But of course, there is a very big price to pay. Those apps are not designed with the sort of the person who will use it in mind. Those apps are designed to maximize a person paying attention to the app so that the app can show you as many ads as possible. So the incentives are totally wrong right now. And all of this software that we use that supposedly is helping us with different problems like Facebook with socializing with friends and so on, ultimately their customer and who pays them is the advertiser. And so they design the whole system with that advertiser in mind, as opposed to trying to really have the best interests of the consumer in mind. So I think we have to change the business model and go back to paying for apps, paying for services, so that they can be, the incentives can be aligned with our incentives.
Another question from the audience, from Yuan Yin. Sigmund Freud wrote a famous book called The Interpretation of Dreams.
Mm-hmm.
Do you think the dream may inspire creativity is consistent with it?
Sorry, what was the second?
Do you think the dream may inspire creativity is consistent with this line of research?
So I haven't studied Freud in detail, and it seems that he's primarily interested in sort of the relationships between people. But there is a whole field of dream research. And in fact, one of the regular sessions that we are the organizers of is this regular session on dream engineering, we call it. It's a weekly talk series where the dreams researchers from all over the world come together to compare their work and to talk about new technologies for studying dreams, for influencing dreams, for capturing dreams. It is a very fascinating research topic, but Freud doesn't come up all that much in it, although there are definitely some of the researchers in the field, such as a professor in Canada, I believe the last name is Zadra. He collects a lot of dream reports and has fascinating data about what, say, males of a certain age dream about versus females of the same age, etc. He's collecting a very large data set of dreams. So he may shed some light on Freud's theories. Yeah.
A few more questions very briefly. Is your team working on any device that can take someone's life goals and help create an actionable habit or routine and provide gentle reminders throughout the day about a routine to follow?
Yes, very, good question. Yes, we have one project actually that is specifically focused on habit formation. How can we help people with changing behavior and creating habits that they want to have? This is, of course, an incredibly difficult problem. And the approach that we are taking is that we want to basically create certain automatic responses in the person. For example, if you don't floss your teeth often enough, the system will recognize when you are brushing your teeth and then remind you remember, every time you brush your teeth, then you have to floss your teeth. So it gives you that reminder in a certain context so that you can learn that association of the context of brushing your teeth with then flossing your teeth. And we are showing and have shown in papers that that kind of context-based reminder is more effective at building new habits, because the person starts associating the first activity with the other activity that they want to develop into a habit.
Okay, one more question, probably the last question. In your work, you have examined the superworld memory studies and the scent in essence. Is it the context that is the most relevant as it combines the sensory modalities? So the question is mainly related to the context and how this studies combines the sensory modalities with learning skills, I guess. So
the work with essence, so our novelty in that work is that there was existing work by Bjorn Rasch. He's a psychologist in Switzerland, and he actually did studies and several others as well, but he's the most known, related to this concept of targeted memory or phenomenon of targeted memory reactivation. But he did his studies in sleep labs, inviting people to the sleep lab, putting all these things on their body, letting them sleep a first night without engaging in the experiment because they can't even sleep with all the wires. Then the second night they're tired enough that they sleep, and then they engage in the experiment. Our novelty is in simplifying all of that to make it possible to do these experiments at home. So we actually had close to, I believe it was 40 people who took this device home and were able to use this technique of targeted memory reactivation in their own bed at night. And we showed that indeed their memorization is, or their recall is much better than that of people who just got water. So a lot of our work is in creating these devices, and these devices then enable new studies, because now different labs in different places around the world are using our Essence device to do new studies that are much easier to perform because the technology is so much more compact and easy to use.
On that note, I would like to thank you, Pattie, for taking your time to join this presentation today and giving this inspiring talk. This is the end of our session. If you have any further questions, feel free to follow with Pattie, Professor Pattie Maes, by email. I'm sure that there are a lot of students who may, want to do a PhD or move on to a postdoctoral work as well in MIT Media Lab. So feel free to reach out to her if you have any questions. So thank you very much.
Thank you so much for having me, and sorry for not leaving enough time for the questions. So feel free to be in touch. Yeah.
Thank you very much.
Thank you. Have a great evening.
You too. Thank you.
Bye.